plot. And it's also a distribution. It's called a Boltzmann distribution. And now we have kinetic energy on the x-axis. And here, this one's one that I made up myself. The other one was a plot that I got from somebody else, borrowed from the internet, let's say. So this one actually has fraction of molecules with a given kinetic energy. It actually has numbers on it too, but we don't need to think too much about the numbers, although I'm happy to discuss. And while I'm here, let me answer the question. It says, will the next exam be sort of like the first in that we will have 3 attempts? Yes. I hope that's okay. I haven't written it yet, but I know that will be true. And otherwise, it will be similar to that as well. So with kinetic energy on the x-axis, I think there's a stray period there because this is the same sentence. For nitrogen gas at 300 Kelvin, please add lines or curves to the plot for the following. Nitrogen at 600 Kelvin, oxygen at 900 Kelvin. Please also point to the most probable kinetic energy and the average kinetic energy for nitrogen at 300 Kelvin. Okay, so there's a lot to do on this plot. And the first thing I need to tell you, and this is in the lecture outlines, is that average kinetic energy, that's the bar means average, is proportional to temperature. And of course it has to be absolute temperature, meaning in Kelvin, but everything is in Kelvin for this problem. And I will only ask you this problem for Kelvin. So, and this is true for all gases. So, for all gases, it is the same curve. Let's say this. At the same temperature, it is the same curve. So it doesn't matter really whether I'm asking about nitrogen or oxygen or carbon dioxide or krypton. If kinetic energy is on the x-axis, the curves are all the same. So now what I'm going to try and do is I'm going to try and answer A. And for A, I need to do 2 things. One, I need, if the temperature is doubled, then I need the average kinetic energy to be doubled. And I guess now would be a good time for me to point out where the average kinetic energy is on this plot. If you were to average all the kinetic energies of all the molecules in this curve, it turns out that the average is right about there. It's a little past the hump, or the high point, and that's because there are some very high energy particles out here. So now, as best as I can, this is my 300 Kelvin one. I need to draw a 600 Kelvin one that doubles the kinetic energy at the average. So here's what I'm going to do. We're going to start at 0. I'm going to go up. And I'm going to start coming down so it matches that just past the hump. And then I'm going to start going down like that. Because the second thing you have to do is that the area under this curve is the same as the area under the black curve, or the 300 Kelvin curve. And that's similar to the last problem that we worked on. And again, one idea is as temperature increases, it's like you're squishing this curve over to higher kinetic energies. So this is going to be the one for 600 Kelvin. And then I'll change colors for 900 Kelvin. And 900 Kelvin should be 3 times the 300 Kelvin. So somewhere out here. And now I'm just going to go, I don't know if I'm going to do this. That one's starting to look like Patrick from SpongeBob a little bit, but it'll do. I mean, we don't have to be perfect here. It's not an art class. But so just as long as you get the idea that it's somewhere, the average is somewhere past the hump or the high point, and then it's roughly 3 times, so for 900 Kelvin, the average kinetic energy, which is represented by this dot, is approximately 3 times the average kinetic energy at 300 Kelvin. And don't worry, I won't be measuring. Just do your best, which I'm sure you guys are doing a great job of that. Oh, I'm not done yet. Let's see. So always reread the question. So now I've got N2 at 600 Kelvin. I never even talked about what gas it is. It doesn't matter what gas it is. Oxygen, nitrogen, carbon dioxide. They're all the same if at this, so at 900 Kelvin, all gases have the same kinetic energy distribution. Okay. All right, so keep reading. Please also point to the most probable kinetic energy. The most probable kinetic energy for each of these is the highest point on the curve. So I'm just going to point to that. Most probable kinetic energy. And average kinetic energy for 300. And for average kinetic energy, you can just do KE bar. Right, and that's my 300 Kelvin curve. So that's this curve properly annotated. Any questions about that? Okay.